AP Calculus AB, we're in section 5.5. This is the second video, and we are getting into the meat of it, the similarities and differences between net distance and total distance. Definition of net distance, which you could think of as displacement. The distance between the point of origin and the final position. Definition of a total distance, the sum of all distances moved in any direction. If you think about most people that are in our class, from birth to now, their net distance traveled is likely less than 15 miles. To determine your net distance traveled, it's real simple. Ask your parents what hospital you were born in. Go to Google, put that in Google Maps, and then put also in Google Maps where you are currently, and measure the distance, as the way the crow flies, between your birthplace and where you are right now, and that is your net distance traveled. Total distance traveled is a lot more complicated. You would have to go back, put a GPS strap to your back, and you would have to measure every time you moved from when you were born to now and add up all those distances together, ignoring in which direction that you're going. That would be the total distance traveled, and it would be, I would say, literally impossible for you to figure out. If the particle is moving in the same direction the entire amount of time, what can be said about the net distance and total distance? Well, in this case, the net distance would equal the total distance. I want to make sure it's clear. This is not true in all contexts. It's only true if the particle is moving in the same direction the entire time. So if when you were born, you decided that you were going to start walking east, and let's assume that the flat earthers were right and the earth was flat, and let's say it was also infinite. If you decided to walk east and you only walked east for your entire life, your total distance traveled and your net distance would be identical. That is a rare instance for that to happen. To find the net distance a particle travels on an interval, you are going to take the ending position minus from the beginning position, and you can do that in either order, and then take the absolute value, because we want this distance to always be positive. To find the total distance traveled, every time you change direction, and right now we're assuming that we're only moving horizontally, left or right. Every time you change direction, you create a new C value here. So let's say that you start at position A and you go until you get to position C and then you change direction. You would find that distance, that net distance, by subtracting those starting and ending points and then take the absolute value. Then you would add to that wherever you turned around, minus the stopping point that you had. So if you turned around once, you're going to have 2 of these. If you turned around 8 times, you're going to have 9 of these things. Every time you change direction, you need to do one of these. A little complicated. Hopefully when we see some real examples, it won't be so bad. Please note, T equals C is where the particle changes direction. If we change direction another time at D, this would be P of C minus P of D, and then add to that P of D plus P of B. Note that A and B are the starting and ending points for this. That concludes the second video, net and total distance. We will look at some examples in the final video for this section.